Sounds like I'm good.
It's good. Well, hey, this is Dan. He is another one of our amazing developers here, working on a variety of different projects. Recently got off some stuff with a utility, a big utility back east on an island with about 8 million people, trying to keep the lights on back there, if you can guess which one that happens to be. So anyway, without further ado, Dan, take it away, man.
Thank you. So you've probably already seen the title, and before people get angry about what is happening here, we'll get to it at the end. We'll talk about what .NET does well, but today we're going to be talking about machine learning. Is it blasphemous to do this? You know, if you're a Python developer, it probably is, but if not, it probably still is bad because it's .NET, and it's going to be bad. But that's what we're going to be talking about today. I have a QR code for the Git repo to talk about what's going on, and then just a little bit more about myself. I think we already talked about, but I am a software engineer here at IntelliTech, so that's where you're here currently, and I also run the Spokane .NET user group. So please come if you want to hear more about .NET. We do monthly meetups. We actually have one next week, so to talk about all of the things that happened last year. We're going to be partnering with the Python user group, so we're going to be talking about all things 2025, the outages, and AI mainly. But moving forward, so the background and domain of this project, in my free time, I like playing tennis, so we're going to talk about some of the things that, you know, if you're not a tennis player, some of the things you need to know about tennis and why I went with this. But then we're going to go over architecting the model, usage in .NET, and then we're going to compare it against Python, and then finally some takeaways and next steps about machine learning in .NET. So first, with the background and domain, I have a pretty boring life. How I spend my time is coding, tennis, making up these little graphs, and then cats. So you know, this has no bearing on actually, but I thought it would be helpful for a little bit of why I chose tennis. So when I originally did it, I wanted to just start coding an app. You know, this was from Kevin. I wanted to use Aspire. So this app is an Aspire app, but I want to just use it. I've never used it before. I was onboarding into a new project that used it, and I wanted to kind of learn a little more of the intricacies of just, besides just the, okay, go here and then run it. So that's one thing. But then the actual app that I came up with was, okay, what hobbies do I have? Well, I like doing mountaineering projects, but I don't want to write an application about mountaineering because then if I get something wrong, that's life-threatening. Okay, so tennis is another hobby I have. Okay, tennis is kind of a hoity-toity sport. People, when they go to coaches, that's like, you know, there's a lot of stereotypes about going to a tennis coach, but it's very expensive as well. And when you go, it's like an hour-and-a-half session, maybe 90 minutes, where they like learn about you as a player and then give you tips. So they don't know anything about you before, they don't know anything about you after. So personalized coaching tips is part of the vision of what I was trying to go for. And breakpoint, for the context, when you are serving, you should win your game. So if you are about to lose the game you're serving, you're on breakpoint. So that's where breakpoint is, and then AI is obviously because I'm using AI. And then second is tracking over time. So like I said, a single expensive coaching session is only a snapshot. So a system that can learn patterns as a player, or learn about things that you didn't like that it recommended. And then finally, free, right? So tennis and other sports already use these kind of kinesthetic models to improve players, right, at the professional end. How hard could it really be? And of course, I have the tendency to say, oh, how hard could it be? I'll just do it really quick. Not easy at all. So getting into a little more of the actual technical things, and please stop me if I'm going too fast or if you have questions, and we'll do a Q&A at the end as well to kind of review some of the things. But if you have questions, please raise your hand. So architecting the model. So with all the capabilities AI has, and Grant talked about it earlier, things are becoming cheaper to do that used to be really cost inefficient and really hard to do. So with the capabilities it has now, especially for personal projects, start at the end. And what I mean by that is instead of like picking a certain path, then finding out the pitfalls it has later, start with the end things that you want it to. What are the ideals or what are the needs of the project? So, and once you start having those needs, it kind of kicks down the can and say, okay, now I need to answer this architectural question. Now I need to answer this architectural question. So some examples, I wanted to take just videos of tennis. So you play and then you upload the video. So that asks the question, how do I get either numeric data or how do I analyze that data from videos? And there's a couple different ways we'll talk about. The second is provide accurate coaching feedback. I like playing tennis. I wouldn't say I'm a particularly amazing tennis coach. That's why I do software engineering. So how do you actually get like real coaching insights from just a video and plain data? And then finally, don't rely on overly labeled data and an expert up front. So I'm lazy. I don't want to sit there labeling hours and hours of tennis videos saying, well, his footwork was bad, his elbow was too low, his swing was too short, whatever, right? I didn't want to do all that. So where do the coaching insights come from then? So to start, the input. That's kind of the first question that I had. How do I process a video? So there's kind of some typical standard ways that you would approach a video, right? Multimodal models are now kind of the cool thing to do. You just give it a video and say, analyze my video. So the pro is that it's really easy to set up. You just have a model, call it, send the input. The con is, how do you make it structured? How do you make it more specific to your domain, right? You can ask really nicely in the prompt, please make it a good response. But besides that, it's a lot harder to control, especially with the new models. And so an image classifier, you get a lot more control because you're actually taking, okay, I have a structured output that I'm going to get, and I've defined the set of labels. But, like I said before, I'm lazy, so that requires a lot of data. So that was the original approach I had, and then I started looking up how much data I would need for like a simple Azure vision to be at all good. It was a lot more than I thought it was going to be. So then finally, pose estimation. Kind of the original spark of the idea was those videos online where you see the person's joints and then an AI summary comes up and it's like, your elbow is too low. So I looked up, there's some free models online that Google produces called MoveNet. It's a pose estimation model, and it points out 17 key joints. So technically you get your eyes and ears as joints. Sure, don't use them, but sure. But knees, your hips, your elbows, your shoulders, all those things. So that detects 17 key points in a body, and it's really fast. So, okay, how does joint position correlate to a good swing? Now we're just iterating and going forward and forward and forward to try and answer the question, okay, now that I've kind of chosen this path, what are the results? So how does joint position correlate to a good swing? So some of the problems are in tennis, there's multiple swing phases. You're not doing the same thing over time. When you do a tennis swing, you swing back, you swing forward, and then you follow through. And then swings are not the same, right? A numeric analysis of joint data wouldn't make sense because not only is each person going to be different, but also the video angle might be slightly off. So we can't make overarching rules based on the numeric joint position data. And then finally, there's a lot of data for rules-based. So if it's by frame and there's 17 key joints, and we have other features as well that you can calculate, and we're not going to use the nose or whatever, but there's over 400 frames in a 15-second video, assuming 30 FPS. So there's too much data for us to do anything meaningful with it. So moving into my initial design, we have an Aspire app that at the top, you have an Angular app front end that uploads a video, does all the basic things, so that this top half is pretty basic. But then you get into how do you actually generate the analysis. So the way I ended up initially doing it was I have a custom AI model that I used that was a classifier. So it was a regression, fast tree model. If that matters, it doesn't really matter. We're going to change it a couple times. But initially, it was leaves and nodes. So you generate. I trained the custom data on some labeled videos of this is how good the swing is, right? So I had pro videos, I had beginner videos, and they were just really simply, okay, this video had swings that were of quality 0 to 100. And initially, it was actually USTA rating. So USTA is 1 to 7, so pro is 7, but it doesn't matter. It's 1.0, So that'll change, but so MoveNet, I take each frame and get rules-based creation of the swings for each joint, send it into a swing analyzer, output a USTA rating, plus the highest negative weighted feature as the form indicator, and I'm going to talk about that in a second, what that means. And then I just send it to OpenAI and say, please take this whole kind of more technical analysis and give me some drills as a list of strings. So let's talk about what this highest weighted negative feature means. So in AI, now that I've trained, and we'll get into the code a little bit in a second, but when you have AI, right, you have a list of features. So each feature becomes in the fast tree model or different, it becomes a weight at the end of the line, right? So maybe it's your elbow, wrist, and shoulder angle becomes a feature that then can contribute, 0 to 1 to the output. So in the case of for this model, the shoulder angle was really highly rated because what it meant is this score, this difference of numeric value, highly correlated to the result. Pros all kind of had the exact same shoulder angle, and beginners kind of had a really bad shoulder angle, right? Because when you see a pro hit a tennis ball, they're really loose, they're coming through the whole ball. But a pro or a beginner, they kind of do this thing where they're just it's like a ping pong, right? So it's very different. So this was my initial design. And the reason I bring this up and the reason I'm getting into the technical details is because I was not sure initially what I wanted to do, but a lot of this planning was done with Copilot. So that's kind of a final takeaway, but we'll get into that. So this was something I was like, okay, we're using kinesthetic data. We have a bunch of arrays, basically, of floats where it's showing the position. How does that mean anything? Okay? But the middle part of this rules-based creation of the swings, so for each phase, I basically had a bunch of rules trying to dictate how do you determine a swing. And I was having really hard time writing that code. So I said, well, maybe AI will do it better than me for writing the code. So I said, okay, just put another model in the middle there. And I take, instead of you doing rules-based, I basically just take all of the arrays, and for each frame, classify it as a different swing, or as a different swing phase. So back swing, contact, and follow through. So then now I'm taking the hard parts of the code that I was writing myself and just throwing a model at it in C#. So then I changed some other things, not as important. We can get into the details a little bit later. But let me show you a little bit about what this looks like, because I can talk about it as much as I want, but even my eyes are kind of glazing over, so I just want to get into a little bit of what that actually looks like. So like Kevin was saying, oh, that's not where it is. As Kevin was saying, nice, pretty graph. Demo's really great. This is my Aspire host running, but the only one that matters right now is the front end. So I did the back-end coding, and I was like, oh, I want to throw a pretty little UI on front of it. AI, go do that. You do that while I'm coding over here. So it does work. We'll see. So I log in. I have a user that I need to create. It just blew away my database. And a couple things, I give it a USTA rating and a dominant hand just so the AI doesn't have to figure those out midway, and the drills are recommended based on how good you are as a player, so that's the reason there. Okay, so let me pull up my video that I took this morning. I went and to my tennis club, went to the ball machine, and hit some tennis balls this morning. So right now I'm just doing backhands. So this is the video. I haven't uploaded this, so we'll see what the outputs are and see if it's at all good. But it's basically just 30 seconds of me hitting a bunch of backhands, and that's it. So we'll upload that as the type backhand. And that should be the one. OK. And while this is going, I'll talk a little bit about the process for training. So in .NET, the hardest possible thing that I did for this whole project wasn't training the model, wasn't architecting the model. It was actually just loading the first model because MoveNet was a already downloaded PB file on TensorFlow. So TensorFlow is like this huge Python community of models that are really great, but it was really tough to load. There was like code online in different forums that, hey, it said this is how you upload and use a saved model. Nothing was working. So I was getting a little frustrated because .NET was claiming it could do things, but just not at all working. It was running into like tensor errors or output errors or conversion errors. And I was like, I'm not seeing any documentation. That's the one problem with machine learning in .NET is that the documentation and the support in the community is just way lower. Okay, so we iterated a little bit, me and Copilot, and I was like, okay, well, if the standard way in Python isn't working, let's go to like a universal. There's a AI format called ONNX, that basically it's a frozen image of the AI. So you upload that. So I converted the model, so the MoveNet model, and then tried to upload that. And I was using all the different, so ML.NET is a library. There's TorchSharp. It's kind of the equivalent to PyTorch. And I used, then there was finally an MLNet Onyx. That was the one that finally ran. But the hardest part was actually just running the model, which is kind of funny. And it should be SignalR based and show when it's done. OK, well, whatever. OK, whatever, didn't work. But so now we have a couple things that appeared on this page. So the first one is a training progress summary. So the thing I said earlier, I want to have a AI learn about me. But if I have 50 plus analysis, I don't want to load that into the whole context window and have that learn. So the way I ended up going about that was there's a progress summary. So after each analysis, it goes and generates a summary about what happened last. So this is a little spoiler about my score. And the current, where's my mouse? The current model is 0 to 100. So 100 would be a pro swing. And it looks like it gave me a 66. So it looked like the key frame that it didn't like was, and here you can see what MoveNet is taking in. So the joints that matter, looks like my knees, my hips, my shoulders. I got my nose in there. And then the wrist. So it looks like this is the thing that it didn't like. It didn't like my backswing the most. So we'll go down. Yeah, so it looks like the backswing, the contact, and follow through were all kind of average, which is pretty accurate for me as a tennis player. I'm like an average tennis player. I like playing, but don't have anything specific. So recommend some drills out here. Perform shadow swings, focusing on a low to high swing path. Start with the racket dropping low. So very specific drills that then, if I mark as complete and I find not helpful, and we'll see if the AI is being helpful today. So what I did there, to clarify, is I said it wasn't helpful because my problem area actually isn't the one you identified, but instead my preparation. I was too late to hit the ball in this case. I didn't actually know. I just was figuring out. So on the next analysis, it should take that into account. So we'll upload another video, and I'm suddenly going to get really good at tennis because we're going to upload a video of a pro. And let's, I gotta go pull the video. So the video I'm now gonna pull is a video from a guy named Yannick Sinner, who is the #1 tennis player in the world right now. And he is better than me at tennis, surprisingly. So for some reason, I don't know. He's my age, which is also very upsetting. So here, we'll watch his video, actually, because I think the comparison is going to be good. So this is him warming up. So you see it's spliced together, so it just backhands because you need to be by stroke. But yeah, a little different. He's a pro tennis player. And he's also European, so he's just going to be better than me at tennis. That's just how it goes. So we'll upload that, and while we're talking about it, we'll figure out what's going next. So what we just saw there was a combination of 4 different models. And in reality, it's actually 6 models because I've added models, so it's per phase, so you score them. But that's really hard code to write that then suddenly becomes an AI task, right? Then you have other hard parts of the code where it's, oh, how do you figure out what's important in features, or how do you figure out how to train the model? You have to have good data then, but the problem scope changes, right? And we're going to shift back to my PowerPoint to go to the next step while it's loading. So some takeaways and next steps. So some of the things that I learned while doing this was this stuff, but I'll talk about that in a second. But the biggest one is actually the iteration with Copilot. Because initially I came to it with I wanted to do an image classifier because that's what I know, and that's what's in Azure, and I'm going to spend Azure bucks because those are free for me, and I don't want to do other things. And this was the approach I had, but in reality, that it didn't actually fit my thing. It was just what I knew. So the second bullet point, use the right tool. I wasn't using the right tool because I was doing what I knew, right? And I think a lot of .NET Conf and these things are trying to expand what you know, what you're comfortable with, and use the right tool instead of the one you know. I'm just going to get some water real quick. But now we'll go through each of these. So the first one is leverage AI. So just start iterating, approach problems with a new tool. And I don't just mean Copilot, but I also mean as a feature, right? Don't be afraid to replace bits of code or services. And you have to do it judiciously. You can't replace a database update with, hey, AI, you go do the database updates on the simple code, right? That doesn't make as much sense. But these complex bug paths, or these hot paths in your services where you're trying to do a lot of fuzzy things, AI is going to do better, if not amazing, at what you're trying to do. And don't be afraid to stretch your simple little CRUD app just beyond a little chat window. I know that's the cool hip thing that Microsoft wants to do, but it's not. Guys, it's not that cool, I swear. The second, like we talked about, using the right tool. So we'll get to it in a second. I'm going to use the P word. But I wanted to do this in .NET because that was the talk. It's .NET Conf. It's not whatever. But as much as I love .NET, use the right tools throughout the whole process. So we'll talk about later the next steps. I rewrote. The model that I initially actually wanted to do and Copilot recommended was a 1D CNN. So it's kind of has more temporal knowledge because one of the problems with my current approach is I kind of have to give it all the meta data about what happened before and what happens after in this swing. So right now it's kind of more frame by frame, so you get some over-reliance on single frames. So like the one I pointed out, I don't see anything particularly wrong with that frame compared to the rest. I would actually have said, in my swing, it's the follow-through generally that's bad. But use the right tool. So in the later app, I'm going to be changing this to be a Python trained model, but then I'm still loading in .NET. Because the reason it's nice to load in .NET is because then I don't have to use new code to do the rest of it, right? When I run my Azure function, what's actually going on is I'm taking an analysis request that's from the database, that's a shared model in my EF Core project, and then updating this analysis request with an analysis result. So all of that code is pretty simple EF, right? It's just take item from database, load up this service call to get the result, and it's basically just getting a score, and then I'm calling out to semantic kernel to then get my coaching feedback, and then I have this whole entity table of the recommended drills, which you can then leave mark with feedback, or then you have to load up the history. All that stuff I want to do in .NET. Like, I'm a .NET developer. EF Core makes sense to me, but the tool wants to use Python in the middle. But I can still load a model and have just as much success, but train the model in Python and then deploy the model in .NET. So moving on to the third point, steal others' work. Like all great artists, developers are great at stealing others' work. Copilot is basically just a really good thief. because it's just taking other developers, right? I don't know if people have seen the recent Stack Overflow questions rate. It's basically plummeted since AI came out in 2022-ish, when questions basically dropped because people stopped asking Stack Overflow. Now they're just asking Copilot to really just look at Stack Overflow. So we're still stealing others' work, we're just doing it with extra steps. And don't let AI people tell you they're not stealing. But, so steal others' work, right? In this app, I'm using MoveNet. MoveNet is a pre-trained model that's going to do better than I've ever done on a custom model because they have lots of data, they've had lots of time, and they're better engineers probably. So utilize pre-trained models for answered problems or as part of your solutions, and that extends to things like Azure. Like, don't rewrite document intelligence. Document intelligence has been done well, and there's other ways to do it, but like if you specifically want document intelligence, don't reinvent the wheel. So that's the other thing that's kind of important on this thing. And then finally, build cool stuff, right? Find your passions, find a gap, and just build something, right? This is the time, and whether it's vibe coding or not, the speed up of development has been really cool. Like personally, I had never done big projects before. Like I had college projects that were on my portfolio. I did other things, in prep for job searches when I first joined Intelitech, but like I had never really done something that I wanted to do. I found that to be a scary thing to do, of like, oh, I have to like know so much knowledge and have to have so many things configured to just start the project, right? To set up, and we're also in a time where it's a lot easier. Aspire makes distributed applications easier, but still, you kind of have to like, oh, I have to be able to set up a database. I have to be able to know and choose all these different things. I don't even know the choices, right? But just start doing stuff, and it's going to be super fun. That's all I want to say here. We're going to go back and see if I get my analysis result. And I swear, I promise you, this was working before, where you didn't have to refresh the page. Whatever. Oh, the AI did not like the pro swing. So that is interesting, because when I upload it on a different account, he always gets high marks. The AI likes Sinner. He's part of the training data, so he should be liked. Apparently, I am much better than him. Let's see, 64 versus 66. Okay, not bad. But if we see the updated training progress, Daniel Olvera continues to focus on refining his backend, and that's just because I only uploaded backends. I also had forehand videos with ongoing challenges in backswing position and contact timing. Wow, so it really doesn't like me. New drills targeting horizontal racket placement and wrist snap timing built on previous emphasis of low to high swing path. So progress is steady. That's funny. So this is the result. So if you saw at one point, it called out what frame it didn't like. It called out this frame in the GIF. It's a little too fast. It generated too high of an FPS apparently. But it really doesn't like this. What is it saying here? It's too small. It doesn't like the follow through. So let's look at what the follow through recommendation was. It really likes this low to high thing. Shadow swings with the ball toss instead of pure shadow swings. So this is kind of in response to me saying I didn't like the shadow swings. So instead of pure shadow swings, toss the ball slightly higher. So that is kind of the result of, and that's, yeah, so this is the one problem with AI in demos. It's variable every time. But let's get back here. Okay. So any questions before I kind of go on to next steps and then wrap up and go into a QA? Is there any thoughts? Go ahead, Chris.
On step 2 there, use the right tool. So why is Python self-evidently better than .NET for what you're doing?
Yeah, so, where did this, did I skip this slide? I skipped this slide. Dang it. Okay. So Python, the biggest reasons Python is better than .NET is the mature framework. So the number of models and actual architectures of AI that Python has access to is just more than C#. So like specifically, C# has a lot of the basic models, right? Just tree models or simple regressions or like gradient models. But anything that's like temporal based, it's just not going to have support for built into the framework. So if you, because of the way the code, and yeah, it looks like I skipped slides, so we'll get into the actual code in a second. but the frameworks are just better. So like PyTorch, scikit-learn, TensorFlow, those are just better than the C# equivalents. But second is the large community, right? It's just momentum that C# isn't the AI language. Python is, right? People, when they want to do AI, gravitate towards Python. So because of that, they have a larger community, people developing really amazing models, helping others, and just have more code to train on. So there's a lot more rapid advancements in this way. And I think more simply, for like POCs, which is a lot where AI kind of lives, Python is just faster to set up. Did that answer your question? And then for C#, why I would use C#, I mean, it's C#, right? So in my mind, it is like pretty close between these two, but in reality, there are some advantages that are, besides developer familiarity. I think the biggest one that I found was consistency in code, right? So like I said earlier, you're talking to a database, you're interacting with blob storage because that's how I've architected this thing. Now I can do those in Python, but I know how to do this in C#, and I might have code already in a service to do that, right? So on the front end, right, the GIF of the person doing the swing and having the MoveNet, that was all from blob storage, right? So I have code to already interact with blob storage written before, so why not just leverage that code again? I don't need to have duplicated entities. I don't need to have duplicated services in Python if I'm using C# throughout the stack. And I'm going to go back because I definitely just skipped slides. Yeah, so right after the demo. OK, so the usage. So there's a couple things that I'm going to point out, and I'm going to zoom in on them just so it's a little easier. That's not what I wanted to do. OK, so ON and X is the universal kind of, it's a universal output for models to be loaded because it's basically freezing what the AI graph looks like, so you can call it. But it's very simple, right? So session option. Session is just kind of the AI inference session that they call it. I happen to put this just so it's, because I'm using floats, it required this little flag. But then I just load the model. And the model is just a saved .onnx file in my repo. So I actually have it committed because those files, because they're frozen graphs, are pretty small, right? There's other kind of formats that like Python uses, like .pb files, where you have the variables in a different folder. Models aren't that big. Just a pure regression model is pretty small in terms of like actual file. Like you can use GitLFS to throw them in there. But this is how you call a model. So this 3 lines of code took me over a week because I could not figure this out. And I used like 3 different libraries. But yeah, that was actually the hardest thing to do. The second one, the pipeline. So in the idea of machine learning training, you have an idea of a pipeline. So the pipeline is what you actually are training the model in. So in this case, I have some transforms. So I take the data, I transform it using features. Features is the label I have for it using z-score. And that's just so, if just basically normalizes the data so it's more understandable to the AI. I have a multi-class classification there. And then the multi-class classification is when I'm actually training. So it's of the light GBM. And I tried different models. And that's the one I found the most. But it's just a tree model. So it trains for 300 iterations or until it's getting worse, basically. And then I get out a predicted label. And then finally, before people just be like, oh, this code makes no sense, it does not make sense. So let's be clear about that. But it is, the documentation, especially in Python, is pretty good for these different types of classifications. So I actually reference a lot of the Python docs for, because this is using MLNet. MLNet is based on PyTorch plus scikit-learn. They're kind of a combination. Because there is also torch sharp, but that has weird intricacies with it, and I couldn't get working. So yeah, it doesn't make sense, but look at Python and look at better engineers than myself to explain those. But at a basic minimum, it's just training with this number of iterations, right? How many times does it get to try and be better? And how fast does it learn? How fast am I gonna change those weights of the output? So the reason it's changing at 0.05 is because if you change in big jumps and then you're wildly different, how do you know that you just didn't step over what's called a valley or a hill, right? Because when you're trying to approach like a trained model, you're trying to approach a local maximum or a local minimum, depending on what you're going for. Like I'm going for a local maximum. I want it the most accurate, and a local minimum would be a different kind of regression model. But I don't want to step over the big hill that then actually be my solution. So you have pretty small learning rates when you have these number of features. But like I said, this is all gibberish in a general sense, but it works out. And then finally, just the using. So because MLNet has a bunch of conversions that you need to do, you basically have a list of inputs and a list of outputs, just like any function, but they're just named Onyx values because of the way that the variables are saved. So I have the code all there, but that's not really the important part. It does work. That is what I'll say. But yeah, going back to the Python, this is where you can see these lines of code. This one, Python, that's a one-liner. This one, it's like a three-liner. So yes, C# is always going to just be more verbose than Python, but especially in the realms of AI where tensors are a built-in thing to, they're not a built-in thing, but they're kind of a core thing in Python. So you kind of have to go out of your way to use it in .NET. But that is, I'm just going to skip all through this. That's going to be it. I hope at a minimum you learned something a little bit about using different tools in .NET and using, trying to push yourself beyond what is comfortable, but at the same time, using the right tools for the job. So thank you.
Do you want to do questions?
Oh, is there any questions?
Any questions?
Yeah, go ahead.
So when you're validating the outcome of these models, how do you control for versioning on all of the different models that you want?
Yeah, so
I assume that creates a higher output.
correct. Yeah, so the question was, how do you handle versioning in your models? Because when you change outputs, obviously it's going to change most of the surrounding code. Is that correct? So there's a couple things. So first, in a beta stage, don't be tied to the code, right? So initially, your outputs should be, or if you're changing one thing, don't change the other. So you have inputs and outputs. If you're going to change your inputs a bunch, keep your training and your pipeline the same. So then you're not getting random results, right? If you change two variables, how do you know what's going on? So that's the first thing, is change one at a time. The second is once you have a model deployed, there is ways to version in ML, in ML.NET, the library specifically, just like there is in Python, right? That capability is less built out, but just like anything where you're calling different services and like an API kind of level, where you have a version 1 and a version 2, you're just basically going down different paths. Does that answer your question?
Yeah, and then I guess the other thing is, as you were building this, what was the variability in just the results? Like, if you were to set up, let's say, unit testing or something for known good and bad swings, were you able to more or less see consistent results from the API?
I was. So the biggest thing, and I'll repeat the question, so how do you account for consistency and how do you test for that? So in any sort of machine learning, there is a lot of metrics that you do when you train the model, right? So part of training is validating the testing. So you basically do a training split. So on the training set of data, it doesn't actually use all of the training data to result in the output. Instead, it takes a split, maybe it's 80-20, takes 80% of the data that you've labeled and results, so it trains on the 80% and then tests on the 20%. So it can validate the output. So then say it is really bad at detecting a good swing, it's going to result in a high, maybe R squared, depending on the metrics you use. But in machine learning, it's at the training time when you can validate the variance. That basically each model says, I have X number of variants depending on the metric. So R squared is one, mean squared, the Z-score, all these different kind of metrics that when you train the model you get. And one of the notes is basically, one of the next steps I need for my model is I need more data because I have around like 400 swings pulled out and labeled and stuff, but that's pretty low because it's a 0 to 100 quality score. So it's not exactly mean because I have other things where I'm using an ideal player profile to extract the top derivations of your swing to like, here's what a good player looks like. So I have a lot of videos of good swings and use that to determine as a player, how do you improve, right? Reference these kind of swings and these kind of data. So my distribution is not, it's basically not 4 swings per 0 to 100, right? It's more kind of highly weighted to the end and the beginning. It's really easy to get beginner swings online, really, really easy to get pro swings, right? Because they have matches that are on YouTube. It's harder to get intermediate because they're generally playing random tournaments, if that makes sense. So at the end of the day, more data is going to generally help with variance. But during the training pipeline is when you actually find out. You can, when I ran in this project, there's a console app that I did all the model training from. And also a Python script because I also tried the Python. But for C# stuff, you can output these metrics from ML.NET. And all the frameworks are going to have metrics you can output as from the training pipeline. Any other questions? That was a great question.
The venerable Mr. Sullivan has a question here at the front.
I was going to let you keep time if you're looking to move to the next session.
No, go ahead and ask a question.
So this was a little bit.
Just ask right there, then
All right.
present and repeat it.
So I saw ground strokes for backhand, forehand, low to high, top spin.
Yeah.
So when you start taking a look at other strokes, whether it's serve or maybe a backswing in which you're trying to get the backspin.
Yeah,
approach
like a
shot,
slice, sure.
Sure, exactly. So do you think that you have a lot of work to do in changing the configuration for like test for fitness that's going on in that conversation? I mean, do you have a lot of work to do, or do you think that the way you've set it up such that it can still know the right answer without you having to, I guess, spin a bunch of dials? So
for the first one, it depends on what stroke you're talking about. A serve is going to be a completely different type of hit than any other ground stroke, right? The motion is not at all similar in terms of the joint data. Because it's based on, initially, the input data isn't actually the video. It's going to be that array of joint positions, right? So the joints of this swing versus this swing is going to be completely different. So the serve is explicitly an enum that's different. But in the training data, I actually use slices. So in my training data, Federer is one that I have for backswings. That player is just historically known. He doesn't hit a normal backswing, right? So I've tried to build into the model that it's not necessarily what the backswing looks like, right? There has to be other features that you pull from it. So if that answers your question, so like an approach shot versus a backswing, like a backhand topspin versus a slice shot, depends on the data.
So I guess to answer the question from what I heard you say is that you can enumerate some of the things that are like wildly different, like the serve to the ground stroke, but you think that you've brought enough data in such that you can deal with the variability of somebody's stroke. So I don't know if you can do one-handed, two-hand backhands, but you can take it. I mean, maybe it's a Pete Sampras that I think traditionally had a one-handed.
Yep. Federer has a one-handed.
Yep. And so you're not saying, well, you don't look like Agassi, so you're not very good.
Correct.
Right? Okay.
And so to clarify, this is a little more like tennis domain knowledge. So a lot of it is like based on what I know in tennis, right? So I was trying to not encode a lot of the knowledge of like what kind of player you look like because different players. So have I done that successfully? Probably not, because the data set isn't 10,000 swings, right? But the model and what I tried to do is make it generic enough so that it could be with the right data, right? So part of the next steps is just straight more data, right? Get more of the variance, become more generic, but not change any of the actual code, but just retrain the model to better understand those different weights, if that makes sense. Because one of the biggest things I actually had a struggle with, and one of the reasons I went to a swing phase classifier to begin with from the initial code is what I was doing to test my code initially was I was just running pro swings. And I actually got to a point where my code, my rules-based heuristics for what a swing looks like throughout the different phases was really good for pro swings. It turns out pros are actually good at hitting the ball. But then I trained the data, and I was like, oh, it's great, I'm gonna train my model. And then I put all of the training data in, so beginners, intermediate players, advanced players. Turns out beginners don't look like they're actually swinging a tennis racket. It sometimes looks like they're just sitting there, right? Because some of the videos, it's like this. They're just doing this thing, right? Or maybe it's a forehand where they just go like this, a ping pong swing. Looks very different than a pro, right? A pro's really easy. If every swing you're gonna see from like a video of Sinner, he's gonna have the same kind of load up, the same kind of follow through, because he's a professional and doing it every day, right? So that was actually one of the harder things, was the variance of a beginner, and how do you not overfit to what a swing should look like, but at the same time, fit to what a swing should look like, so then the beginner knows that they're doing it wrong. So that was one of the questions that was hard to do. How do you detect them but not get messed up with them? So thank you, great question.
Awesome, thanks, Dan. Give him a hand. You know what's interesting is that it wasn't like AI could just go and figure that all out all by itself. It took a human being thinking about the process and breaking it down, going through those steps to make it so that you could have something that comes out of it, which I think is pretty amazing.